Hello everyone. In this video, again we will discuss the convergence of an infinite series by using root test. Okay, so what you have to do, as the name says root test, sometimes it is also called as nth root test. So suppose you have given an infinite series an, then to apply root test, nth root test, what you have to do is you have to find nth root of an and as limit n tends to infinity, the value of it. Okay, if this value is less than 1, we say the series converges. If the value is greater than 1, we say the series diverges. This result is not conclusive if the value equal to 1. Okay, let's solve some question. So here, if you look at here, this is your an. You can simply write it as ln of n over n, this whole to the power n. So in this question, you will have an as ln of n over n and this whole power n. So for nth root test, you have to find nth root of an. So this is same as ln of n over n, its power n, and its whole power 1 over n. Okay, so this gives you an as ln of n over n. Now, what is next? You need to find its limit as n approaches to infinity. So for finding that limit, n approaches to infinity of an is same as limit n approaches to infinity of ln of n over n. So as n approaches to infinity, we say that the upper limit goes to infinity, lower term also reaches to infinity. So it is in the infinity over infinity form. So we cannot solve it in this way. So we have to use the L'Hopital rule. So what it says, take the derivative of numerator and take the derivative of denominator separately. So this is same as limit n approaches to infinity. Derivative of ln n is 1 over n. Derivative of n is 1. So this gives you limit n approaches to infinity of 1 over n. And this approaches to 0. Because as n goes to infinity, you have 1 over infinity, which is 0, less than 1. So this implies that this series n from 1 to infinity, ln of n over n over n converges to 0 by using the root test. Okay, let's take the next example. So what you have here, your an is this entire term with the power n. Okay, so let's write an is 1 over n minus 1 over n square and its whole power. So what will be the nth root of an? Definitely this n will cancel. So you'll have 1 over n minus 1 over n square because here it's power n and then again the power 1 over n. This cancel, giving you 1 over n minus 1 over n square. Now finding the limit, as limit n approaches to infinity, nth root of an is same as finding the limit n goes to infinity of 1 over n minus 1 over n square. So this gives you 0. So it means again this infinite series converges to 0. Let's take another example. In this case, this is your an. Okay, so an is n over ln of n whole power n. Now, if we take the 1nth power of both sides. So by using the law of exponent, what happened? This power will go to n and as well as to the denominator. Okay, so this gives you n power 1 over n divided by ln of n. Okay, Now finding limit n approaches to infinity of an power 1 over n, which is same as limit n approaches to infinity n power 1 over n over ln n. Okay, and for this you need one result. Okay, that result says that, I'll write it here, limit n approaches to infinity n power 1 over n. This value is always 1. So as n approaches to infinity, the upper term approaches to 1, the lower term approaches to 0. So you get, infinity. So you get 1 over infinity, 0 less than 1. So it means your integral converges. Okay. Similarly, you can work over here. It's almost similar example, just you will have 1 over 2. So here you will have ln and power half. Okay. Let's take another, this one. So En is n factorial, its power n power n, and its power 2. Taking the nth square root means power 1 over n. So it means power 1 over n. So what you can see here, this n get cancelled with this n as well as this n. So you left with n factorial over n square. This is your nth root of En. Now finding as limit n approaches to infinity, an 1 over n. Same as finding limit n approaches to infinity of n factorial over n square. So as n approaches to infinity, both numerators and denominator approaches to infinity. So for this limit, if you remember n factorial, what is n factorial? It is having the terms n minus 1, n minus 2, and so on. And in denominator, you have only n squared. So you'll see that this limit approaches to infinity, which is greater than 1. Hence, this series diverges. Okay, let's take this example. Let's see example number 6. So you can write an as 6 over n plus 1, this whole power n. Taking the nth root, we left with only 6 over n plus 1. Then limit of nth root of an is limit n approaches to infinity 6 over n plus 1. So this is 6 over infinity. That gives you 0 less than 1. So your this series converges. Let's try these two examples, 7 and 8. So this all is your an. Okay, so let me take the nth root. Let me write direct. Limit n goes to infinity, an to the power 1 over n. The same as limit n approaches to infinity, 4n plus 3 over 2n minus 1, correct? Because when you take the nth root, this n get cancelled. Now, you see the n in numerator and denominator, so divide both by n. So this left you with limit n goes to infinity, 4 plus 3 over n. Here 2 minus 1 over n. As n approaches to infinity, you will have 4 plus 0 because 3 over infinity, which is 0. 2 minus 0. That gives you 4 over 2. That is 2. 2, correct? Which is greater than 1. So this implies this series diverges. Okay. Now here again, this all is your an with 3 because you don't need this. Actually, this all is your an. When you take the nth power, this n will get cancelled. So you will have limit n approaches to infinity, a n to the power 1 over n. Same as limit n approaches to infinity, you'll have minus 3n over 2n plus 1 is whole power 3. Correct? Because when you take the 1 by nth root, this n cancel with n. Okay? So if you practice more frequently, you can easily able to do the calculation start. Okay? Now, divide both sides by, both numerator, denominator by n. Only the inner one. So actually we are dividing by n power 3. Okay, so this is equal to limit n approaches to infinity minus 3 over 2 plus 1 over n. It's whole power 3. So what this will give you? Minus 3 over 2 plus 0. It's power 3. As n approaches to 0, only this term, n approaches to infinity, this term becomes 0. It's similar to this, like how this term becomes 0, this term becomes 0. So what this gives you? This gives you minus 3 power 3 over 2 power 3. Okay. So minus 27 over 8. Okay. So this value is less than 1 because negative. So this implies the series converges. Okay. I hope now it is clear how to solve the questions by using test.